Hello everyone, I'm Chamadhi. Recently, I have finished my internship in Emertxe. My internship was an IoT-based home automation, and from here onwards, I'm going to explain what I have learned and finished during my internship. We have learned the basics of C, IoT, and embedded systems. After that, we completed the project for home automation using Arduino IDE, PICSimLab, and Blynk IoT app. First, let's learn something on C programming. C is a general purpose language and it is used in various specific domains. Basically, C is used for system software development, embedded software development, file system development, and so on. This is the basic code of C which we frame for our world. Let's move to embedded C. In here, the data can be represented as several ways, like bit, byte, word, and so on. In there, bit is known as a basic unit of information in computer and digital communication. The two states of bit is 1 and 0, also known as binary digits. And the byte is considered as the smallest addressable unit of memory in computer, and it has 8 bits. Word is the amount of data that a machine can fetch and process at one time. And there are two basic data types, like integral and floating point. Integral has two data types, char and int. And the floating point has two data types like float and double. Let's talk about conditional constructs. There are two basic types, like single iteration and multi-iteration. Examples for single iteration is if, switch, if else, and examples for multi-iteration is for, while, do while. Here are some coding blocks of conditional constructs. And here are some operators we use in C language. We can divide it into arithmetic, logical, and relational. Arrays and pointers are some important topics in C language. Array is a collection of data of same type. Addresses are sequential and indexing starts from 0 and should end at array size -1. In this example, array will have to be indexed from 0 to 4. And we can use array to store data, to group the data, and so on. And the pointer is known as a variable that holds address of another variable. We can get an idea by going through this code. We usually use and symbol for pointers. Functions is also another important topic in C language. When we use a function, instead of writing so many coding lines in main function, we can easily understand, and it is easy to debug and test. Functions are reusable and can be stored in a library also. Like this example, we can use a function and call it in main function when we want it. Let's move to another main topic, which is Internet of Things. Internet of Things means the collective network of connected devices and the technology that facilitates communication between devices and the cloud, as well as between the devices themselves. IoT has a bidirectional communication. It has large complex data flows. IoT is an inflection point because hardware is getting cheap, software is more advanced, and so on. The general technical requirements are many devices, large-scale volumes of data, end-to-end integrations. And the challenges are addressing scale, connectivity, data volume, and device size. This is the reference architecture of Internet of Things. Embedded systems is also a big topic in my internship. Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Some examples are oven, washing machine, TV, security cameras, and so on. We can categorize the embedded systems as standalone, real-time, network, and mobile. These are the components of an embedded system. Let's move to another topic, Arduino. Arduino is a microcontroller where we used to make IoT-based circuits. To do the programming part, we need a software named Arduino IDE, and it looks like this. You can download the software from the internet. When we connect components to the Arduino board, we use pins. Then we can write the program easily. The pin diagram is as follows. In Arduino IDE, all the pin initializations should be written under the setup function, and the rest of the code should be written under the loop function. After writing the code, do save, verify, and then upload it. Here we are entering to the main topic of my internship. It is the project part. In this project, we are focusing on 3 parts. Those are cardinal lights control, temperature control system, water tank inlet, and outlet valve control. Basic requirements for this project are Arduino IDE, Blynk IoT app installed phone, PICSimLab, LED, temperature system, LDR, serial tank, Ethernet shield. Apart from Arduino IDE, we need some web applications for this project. Those are PICSimLab, null modem emulator, and Blynk app. You can download these softwares by searching in Google. And also you need to install your Blynk app in your phone. It is used to control the Arduino. For our convenience, we can use Blynk on browser. Search Blynk Cloud on Google and visit the first link on it. Create an account in there, then go to the template icon, which is in here, and then create a new template by giving the corresponding details. Don't forget to note down the template ID, device name, and the authentication token, because we need those when we are coding. Then we need to do some modifications. In there, go to templates and go to data streams, which is in the top of the bar. Then go to edit, then go to new data streams, and then virtual bin. You have to fill these blanks, and you can fill those things according to this data. Let's move to the design part. These are the components that we need to design this project. And here I got the output, and this is my phone which I installed Blynk IoT app, and this is LCD and Ethernet shield, a temperature control system, LED lights, and LDR. In here, when there is no light, because of the LDR, the garden lights will automatically on. And this is the temperature control system, and I have connected it with my Blynk IoT app. By designing this tab, we can turn on the heater and turn on the cooler, and the temperature is shown in this gauge. And when the temperature is above 35 degrees Celsius, the heater is automatically turned off. And also it shows in here. When we talk about the serial remote tank, the volume of it is 3000, and when the water level is less than 2000, the water inflow is enabled, and after the water level is full, the water inflow is disabled, and the all notifications will show in the Blynk IoT app, and also the main notifications, which is like inflow is off and inflow is on, if the show in your LCD screen. This is the Blynk IoT app which I downloaded in my phone, and I made two tabs, like one for a temperature cooling system and the other one for the cereal tank. These widgets can get from the widget box. In here we can get whatever we want and design our tab. After designing the code and writing the Arduino code, we have to upload the hex file into the PICSimLab. That can be done by like this. And then we can open the spare parts. And this is how I manage the components with PICSimLab. Let's move to the design part. This is the properties of LCD and the properties of Ethernet shield, the properties of a temperature system, the properties of LDR, and the properties of LED. First, let's get the serial remote tank. Then we need to connect it. And here it shows the results like this. We can turn on the heater from the Blynk IoT app in phone. And when it goes to 35 Celsius, it will automatically turn off. Then we can turn on the cooler also. Then we can see the LDR results also, which we planned as the garden light. The basic conclusions of this project are Home automation, the LED temperature system, cereal tank resembles light, heater, cooler, and water tank were simulated by using Blynk IoT application and PICSimLab simulator in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blynk IoT app, like button widgets, are used to control heater, cooler, and inlet value, outlet value. Gauge widgets to display the temperature and volume of the water. And the same internet connection was used to laptop and mobile to connect Blynk IoT application and PICSimLab simulator. Hope you have learned something from my presentation. Thank you so much.